This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. Now we'll cover stopping a vehicle by retarding force. So suppose this is a vehicle which is moving with velocity v and it is subjected to a retarding force F. So after covering a distance equal to x, it stops. It stops after covering a distance. So here velocity is equal to 0 and the whole process, it takes time t. So you have to first calculate the stopping distance, as due to this retarding force, retarding acceleration is generated which makes this vehicle stop. So you have to calculate stopping distance, and these are the various parameters. M is the mass of vehicle, V is its velocity, P is momentum, E is kinetic energy, F is the stopping force, and X is the stopping distance, T is the stopping time. So what should be our approach? Our approach will be that the work energy theorem, which says that F into X is equal to change in kinetic energy, or the work done by a body is equal to change in kinetic energy. If the work done will be due to some retarding force, then it will be a negative work, as the value of force and displacement are both in opposite direction. So clearly, if I apply the work energy theorem, then change in kinetic energy, first I will calculate. So change in kinetic energy is equal to kf minus ki, and is equal to 0 minus half mv square. So value is equal to minus half mv square, and the work done by this force will be minus f into x. So minus f into x is equal to minus half mv square, and we get f dot x is equal to half mv square. So these all things are written here, that by work energy theorem W is equal to half mv square, and we get f dot x, stopping force into distance, is equal to kinetic energy, and the value of stopping force, stopping distance, came as mv square divided by 2f. So x comes equal to mv square divided by 2f. So from this way we can get the stopping distance. So now second, we have to calculate the stopping time. So by impulse momentum theorem, or as we know that as per the Newton's second law, dp by dt is equal to f. So here dp is by dt is equal to change in momentum. So it may be written in terms of this way, that delta p into delta t is equal to f, and from there we get p, delta p is equal to f into delta t. So what is delta p? Delta p is the change in momentum, and its value is equal to pf minus pi. So pf is the final momentum, pi is the initial momentum, final velocity is equal to 0. So we get pf 0 and pi is equal to minus mv. Here also we write f with a negative sign, as it is a retarding force. So minus f into delta t is equal to minus mv, and delta t is equal to t minus 0. So minus f into t is equal to minus mv, and we get t is equal to mv by f. So next time onwards in the examination, you just write directly t is equal to mv by f. So you get the stopping time from this way, and stopping force x is equal to mv square divided by twice f. So this is the two formula, stopping distance and stopping time. Now we will see the comparison of a stopping distance and time for two vehicles. That is, if the two vehicles of mass m1 and m2 are moving with velocity v1 and v2 respectively, and they are subjected to same retarding force. So we just take the ratio of their stopping distance and compare it. So just you have to apply the formula, that x is equal to mv square by f. So f is same, but mass and velocity are different. So for the first vehicle, its x1 is equal to m1 v1 square divided by f, while x2 is equal to m2 v2 square divided by f. So from there we get a ratio x1 divided by x2 is equal to, we get the value is equal to m1 by m2 into v1 divided by v2 square. So basically this is our ratio which is written in there. If instead of their mass and velocity, if they are given in terms of energy, then what will be the option? Then x1 by x2 is equal to e1 by e2. So as the value of force is equal to constant, so it will get cancelled out. So finally we get the ratio of stopping distance is equal to e1 by e2 and is equal to m1 by m2 into v1 by v2 square. So now we can calculate the value of or the ratio of their stopping times, and stopping of time is given by t1 by t2 is equal to p1 by p2 and it's equal to m1 v1 divided by m2 v2. So what kind of inference we can make from these two ratio, we will learn about those things. So these are the different cases. So first I just note down the formula here and then we will see. So first I write that x1 by x2 is equal to e1 by e2 and it is equal to m1 v1 square divided by m2 v2 square, and t1 by t2 is equal to m1 v1 divided by m2 v2. So this is the formula which we have derived, that see this is the formula. So now we will see the different cases. First is the if the vehicle having same velocities, that is v1 and v2 both are same, then what will be the ratio of their stopping distance? So for the same velocity, v1 by v2 is equal to same, and the ratio will comes in the terms of m1 divided by m2. So stopping distance is equal to m1 by m2, and stopping time is also in terms of m1 by m2. So here we get the stopping distance and stopping time are same, that is the ratio of stopping distance and stopping time is same. So suppose a vehicle, both vehicle, I just draw the figure for this. There are two vehicles on two parallel roads and both are having mass, both are having velocity v1 v and v, and mass having corresponding mass m1 and m2. Both are subjected to same force F. Then the ratio of their distance is equal to m1 by m2. Like suppose the m2 is twice m1, like m2 is twice times the mass of m1, then it will take twice the distance to stop and twice the time to stop with respect to m1. So it is written here that x1 by x2 and t1 by t2 is equal to m1 by m2 if the vehicle having same momentum. So in case of momentum, if the both will be same, then the time will be equal to same, as the stopping time is directly proportional to momentum. So t1 by t2 is equal to p1 by p2 and it is equal to 1. So in case of same momentum, the stopping time will be same, however the stopping distance will not be same. So how we calculate? So we calculate in this way, that the stopping distance is equal to e1 by e2, or change in energy. Stopping distance is directly proportional to change in energy for the constant force and is equal to p1 square by 2m. I just write energy in terms of momentum. So for the first vehicle, p1 square by 2m1, and second vehicle p2 square by 2m2. So for the second vehicle, it's p2 square by twice m2. So the value will be p1 square divided by p2 square, and it's equal to m2 by m1. So as the momentum will be same, so we get x1 by x2 is equal to m2 by m1. So clearly, if the vehicle having the same momentum, then the stopping distance will be in the ratio of m2 by m1, or the stopping distance will be inversely proportional to mass m for the same momentum. So similarly, if we say that the vehicle having the same kinetic energy, that is E1 is equal to E2, so for kinetic energy same, the stopping distance will be same. So the stopping distance will be same for the same stopping force. So if I say that this is two vehicle and both having the same kinetic energy, both having the same kinetic energy and same force F is applied, so as both having the same kinetic energy, so mass, so 1 by 2 mv m1 v1 square and 1 by 2 m2 v2 square having same, although mass may be different, velocity may be different, but the kinetic energy is the same in this case, and so the stopping distance will be same. So suppose it stops due to this retarding force after a distance equal to x, then it also be a stop after covering a distance equal to x, and this is our stopping distance. The stopping distance will be same. However, if we have to calculate the stopping time, then the stopping time is directly proportional to momentum, and momentum is proportional to square root of mass and energy. So T1 and T2 is equal to, as we know that P is directly proportional to a square root of twice ME. So T1 by T2 is equal to P1 by P2, and it is equal to a square root twice M1 E1 divided by square root twice M2 E2, and as energy is equal, so E1 and E2 get cancelled out, and we get P1 by P2 is equal to square root M1 divided by M2. So we get T1 by T2 is equal to square root M1 by M2. So the vehicle having a smaller mass will get stopped earlier than the vehicle having than the heavy vehicle, and although the smaller vehicle will have more velocity with respect to heavy vehicle. That is, I just say that if suppose m1 is less than m2 and kinetic energy are same, what it means, if the m1 is less than m2 but kinetic energy and e1 is equal to e2, so clearly v1 will be greater than v2, that is their velocity will be the velocity of heavy vehicle will be less, but the time taken by heavy vehicle to stop will be more, although its velocity will be less. So these are the different concepts. You should keep these concepts in mind, that if the vehicle having same momentum, then stopping time will be same. However, the stopping distance will be inversely proportional to mass. If the vehicle having same kinetic energy, then stopping distance will be same, but stopping time will be directly proportional to square root of mass. Now, what will be the retarding force? So suppose if the retarding force will be a frictional force, like as we know that if a body moves on the surface or a flat road having mass m, then its frictional force will be mu mg, and it comes is equal to frictional force F is equal to mu into reaction force, and here mg acts downward, reaction force acts upward, and we get R is equal to mg. So the frictional force is equal to mu mg, where mu is the coefficient of friction. So you have to calculate the stopping distance. So stopping distance x comes is equal to E divided by F. So as E is the kinetic energy, so initially its velocity will be v, and then it will stop after covering a distance equal to x. So clearly the work by work energy theorem, work done is equal to change in kinetic energy, and change in kinetic energy is equal to E, and it is equal to F dot x. So we get x is equal to E by F. So here E is equal to half mv square and F is equal to mu mg. So I just put the value is equal to in a value for to get the stopping distance. So stopping distance by frictional force will be given by half mv square divided by mu mg, and is equal to v square by twice mu g. So this is the stopping distance. This is the stopping distance. X is equal to v square by twice mu g in case of frictional force. So what will be the stopping time in case of frictional force? So time is equal to momentum divided by force. So momentum is mv and force is mu mg. So we get that t is equal to v by mu g, and the stopping time is equal to velocity divided by mu g. So if the vehicle is stopped by the frictional force, then the stopping distance is equal to v square by twice mu g, and stopping time is equal to v by mu g.